You can see it and can hear me.
Hear you, or the slides. We can see the slides and hear you. Okay,
Good,
please.
perfect. Yeah, thank you very much. And first, of course, I have to apologize that I cannot with you. But finally, after 2 years, it also hit me, and I had a hard weekend. But now I think I can manage to give this talk, and I'm very happy to have the possibility to speak a little bit about APPEC. And the strategy in astroparticle physics, of course, a little bit the European view. I also have to apologize that probably the talk is a little bit too long, and I was not able to shorten it. So I have to do it on the fly, and I hope I can fit into the 20 minutes. First, astroparticle physics, what is it? Astroparticle physics is a branch of fundamental science embedded in environment and society. And in particular, these two things, environment and society, are getting more and more important, as you all know. And we have to deal with it with our research infrastructures and with our experiments to get in close contact with the environment and also with the society. The science motivation for astroparticle physics is understanding the multi-messenger and the dark universe. And on this nice sketch from originally from Johannes Blümer, you can see in principle all the topics which are covered by astroparticle physics. I also found interesting the definition of astroparticle physics on Wikipedia. I can read this. While it may be difficult to decide on a standard textbook description of the field of astroparticle physics, the field can be characterized by the topics of research that are actively being pursued. That means if you feel and if you think you are an astroparticle physicist, you are an astroparticle physicist. And that is quite nice. And I think it is important that our field is not so strictly focused on a specific topic. Okay, what is APPEC? 2 slides to APPEC. It is called the Astroparticle Physics European Consortium. It is an international coordinating structure. It was funded, it's relatively young, in 2012 in the form as we have it now here. It is based on a memorandum of understanding and has a financial agreement with DESI by all the partners. And you also have a little budget of roughly 70 kilo euro per year. So we cannot finance and fund experiments or large-scale infrastructures, but we have a little bit money for networking and workshops and the necessary things. We have at the moment 18 member countries, 22 funding agencies, because some countries has more than one funding agency, and 6 observers from the neighboring fields like particle physics, nuclear physics, astrophysics. Of course, currently we have one suspended member, which is Schindre from Dubna. We have 3 bodies who are doing the work. The first is the General Assembly. This is a strategic decision-making and supervisory body. Here are the representatives of the funding agencies, and we have an elected chair here, which is currently me. We have also a scientific advisory committee, which is advises, so to say, the General Assembly, and which is responsible to follow, to make the strategic decisions, or to give the feedback from the community on the strategy. What is the needs and the requests from the community, from the science for the future in astroparticle physics? And in addition, we have a joint secretary, which is an executive body chaired by a general secretary. And as I mentioned, we have 6 observers currently in the General Assembly. So what are our tasks? There's a long list of tasks and measures what we are doing. The baseline is that we want to guarantee coordination of European astroparticle physics between funding agencies, and also to have, as a research field, visibility at ministry level. And there we have various measures. More on the scientific side, what we want to do is we want to help, in particular in coordination of international large-scale research infrastructures, where it is not possible anymore nowadays to fund and to organize and to coordinate these research infrastructures on national levels. One need a coordination on international level. But in addition, of course, we also want to help in the transition of currently still mid-scale experiments to become large-scale research infrastructures. And what should never be forgotten is the support of small-scale and R&D experiments to make the first step from a small, maybe national experiment to a mid-scale experiment, and then finally to a needed large-scale research infrastructure. In this way, we want to support the astroparticle physics community. One of our main tasks is to build up the strategy and to together with the communities. And here we have the APPEC roadmaps. The first one was submitted and published in 2008. Then we had an update in 2011. And the recent one is that one from 2017, which is called European Astroparticle Physics Strategy 2017 to 2026. Here are the scientific topics which we have defined in this roadmap: high energy gamma rays, neutrinos, high energy cosmic rays, gravitational waves, and so on, but also detector R&D, computing and data policies, and of course also theory is included here. But also there is considered, and this, as I said, is more and more important, organizational issues and also societal issues. Gender balance, education and outreach, open science and citizen science, ecological impact, and also connection and transfer to and from industry. Organizational things, of course, we consider also the ideas and the strategies of our neighboring communities. We have the contact with the European Commission, and what we also need for our experiments are unique infrastructures, and together with the neighboring communities, we consider interdisciplinary opportunities. I want to now give a little impression of what we are currently doing, and this is a midterm evaluation and an update of the roadmap. What you see here is a picture published in 2017 in our resource-aware roadmap. So what you see here was the plans and the ideas for investments and operation costs of the big experiments in astroparticle physics, focused by European funding from 2017 to 2026. The darker colors here are the maintenance and operation of the experiments. The brighter colors are the investments needed. And you see, and at the first view, you can recognize that all these things have been delayed. Also, even as examples, the gamma ray telescopes, where the flagship experiment is a CTA, Cherenkov telescope array. So the investments, the big money is flowing now, and not as it was foreseen here already in 2017 and 18. So and everything here needs an update, and this was the idea, and that we now in the midterm of this 10-year period, we need an update. And first, of course, we have to evaluate what is on this roadmap. Are there new kids on the block? Are there new experiments? Are there new topics for astroparticle physics which have to be considered? And also, of course, we have to update the recommendations given in 2017, and also the update of time and cost lines. What we have done so far is the midterm evaluations. That means a scientific evaluation. What happened in these 5 years here in the roadmap? And this we have done with several workshops, with some sub-working groups, for example, on direct dark matter, or on a double beta decay committee has worked on the future of the double beta decay community, and so on and so on. The timeline now is that we have provided the information to the communities of this evaluation at the end of 2021. We had a town meeting just 1 month ago, a little bit more than 1 month ago in Berlin, where we got a lot of feedback from the national communities. What we start now is that we will do a census, a survey of the time and cost lines of the main experiments here to see what, if we can unblur, so to say, this period of this 5 years and give a little bit of tendency and a strategy for the next 5 to 10 years. And then we want to publish the roadmap end of 2022. So what I will do now is very roughly focus a little bit on the big flagships of astroparticle physics and also from the European view. And here I will try to save a little time. If you are interested on a specific topic, you can either look to the slides here, or everything here, all experiments mentioned, all topics mentioned will also be discussed in much more details in the coming days at the conference. First, going to multi-messenger astroparticle physics. Multi-messenger is required to understand the sources of cosmic rays and the physics processes in the high-energy universe. You all know that this needs long-term operational observatories for gamma rays, neutrinos, cosmic rays, and also now gravitational waves. This plot was already discussed by Jörg, but in my opinion, what is very important in the future, and in particular for multi-messenger astroparticle physics, that we need here a sophisticated big data management that concerns big data analytics, research data management, data curation, data access, and also open data and open science. So let's just roughly through. There's always one slide a little bit on the status of the field. High energy gamma rays, you know, there is a broad energy range to be covered by satellites, by imaging air Cherenkov telescopes, by ground-based arrays. And however, you all know that the main future project within APPEC here is a Cherenkov telescope array. Here a nice picture of the Cherenkov telescope array, how it hopefully look like in a couple of years. And here is a slide on the status. CTA is a ESRI project, so a European large-scale research infrastructure. It is an open proposal-driven observatory, a large number of participating institutes and scientists, and the construction now will happen in the next 3 to 5 years. So now really the construction of the experiment has started. High energy neutrino astronomy, you all know that we have 3 experiments which currently measure high energy neutrinos: IceCube, Antares, and this will go to KM3net, IceCube will go to IceCube Gen 2, and we have also Baikal GVD. There is a large R&D phase of very high end for the measurement of very high energy neutrinos by P1, RNOG, Poema, Anita, Grant. There are many experiments. But again, the European flagship experiment is an ESRI project, which is called KM3net. And but we have here also a strong European partnership of the US-led IceCube Gen 2. So here's a picture of KM3net, and the status is that KM3net is separated in a high energy part, in a low energy part. Both have started their installation. ICAR should be completed in 2026, and OICAR should be completed in 2024 already. Okay, the next point is a high energy cosmic rays. You all know there we have the Pierre Auger Observatory as a major experiment, but there are also future projects like Poema, Grant, GCOS. All of them will also be discussed. And at lower energies, we have LASO and IceCube Gen 2. Here is the Pierre Auger Observatory. And here, the upgrade to Auger Prime is nearly completed. It will be completed in 2023. Then we will have an operation time into the 2030s. And in parallel, there will also be a preparation and R&D for the future experiments, for possible future experiments. Gravitational waves, a very hot topic. 2015, first detection by LIGO and Virgo. And in the 2030s plus, the third generation of gravitational wave detectors. And here we have as a European flagship project, the Einstein telescope, but there's also international collaboration. And one should never forget that the gravitational wave detection comprises a very large frequency range, where Einstein telescope and the Cosmic Explorer are only here at the upper end. Then we have here the satellite experiments, LISA and ELISA, and at the lower frequency range, there we have the pulsar timing arrays, where also the SKA is a very promising instrument for the far future. Einstein telescope as a European flagship experiment, and the status here is that it is now also a S3 on the S3 roadmap. The organization is now that all the boards have been formed, and just a couple of weeks ago, the Einstein telescope collaboration had its kickoff meeting and is now funded with more than 1,200 scientists. And having organized in more than 75 so-called research units. Let's switch the topic now to the low energy astroparticle physics. And Jörg has already mentioned that dark matter has a very broad range and many different experiments. And we in APPEC, in astroparticle physics, in the European astroparticle physics, concentrate here with a future large-scale experiment on the WIMP search. And here we had a subgroup which were investigating the situation now, and they left us with some recommendations. Said, of course, it is important to have the dark matter search. We need a diversified approach. We have to go in the WIMP search to the neutrino floor. We need a coordinated detector R&D. We need for that a European infrastructure for underground science. This is a very important topic. And parallel to the WIMPs, also we have to study the axion and axion-like particles mass range. And altogether, we have to continue with the diverse theoretical activities. Here, as an example for a future experiment, is very promising, the WIMP search with liquid xenon. And here, for example, is what is a multi-probe ID of a next generation liquid xenon observatory. You can not only measure the WIMPs or search for the WIMPs, but also can investigate the sun, supernovas, Big Bang, and is a cosmic ray detector. The status of this WIMP search is here on the example of Darwin, that it is one of the future experiments, but the recent developments have shown that the two communities in the US and in Europe on xenon dark matter search, that means the xenon-Darwin collaboration and the Lux-Zeppelin collaboration, have signed a common MOU and go the way together to find synergies and to be also more cost efficient for the next generation xenon experiment. This is a very important step and a very promising step. The last topic here is neutrino properties. Like dark matter, this science has also a large overlap with neighboring fields. And here I only want of this vast of different experiments and different scientific topics. I want to go a little bit more in detail on the neutrinoless double beta decay, where we are currently on the way towards a ton scale experiment. And here we have 4, let's say, candidates: Qubit, Legend 1000, Nexo, and Next. And the status currently is given in this slide. That there was a double beta decay subcommittee which gave advice on the European and global program. It has here we have a very close coordination of APPEC and the DOE in the US, and also with the SNOMAS progress. And there we had a common meeting of funding agencies, European and North American funding agencies, which led us with the outcome with some recommendations. Of course, first one is a neutrinoless double beta decay should have high priority. The funding agencies in Europe and North America should build a network. And it was decided that Legend and Nexo should be funded because we need 2 isotopes for this search, and from them, 1 in Europe and 1 in North America. That means from this 4 here, Qubit is a little bit smaller. That is not considered as a next generation experiment, but will be built in the next coming years in the Gran Sasso. Legend and Nexo, I mentioned, these are the future experiments, the next generation. And Next is an experiment which still needs some R&D and can be considered as an even future experiment after Legend and Nexo. Okay, this is just to summarize what I said. Here is shown the APPEC flagship research infrastructures. And of course, as you all know, we are in a dynamic research field. So this is not a closed list, but just a snapshot on what we consider today as a future large-scale experiments in the focus of APPEC. This is KM3net and also, of course, IceCube. This is OSHE Prime. Then the construction of CTA, the construction of the Einstein telescope, 1 double beta, neutrinoless double beta experiment, primarily in Europe, which might be Legend, and also a future dark matter experiment, which is based on xenon or on argon, or on argon, let's say. So this brings me nearly to the end. Just one word to the overarching topics in the roadmap. Of course, we consider ecological impact, societal impact, open science and human talent management, which is open data and open science. Here are also some European projects working in this direction. Computing will be a very important topic for the near future. And not to forget that we have also organizations supported by APPEC on theory of astroparticle physics. This is called EUCAPT. And what is also important is a coordination of the deep underground labs in Europe to facilitate a coherent R&D and infrastructure for the underground